Okay, so for this problem, you're looking at sine x over x, and we've actually done this exact problem before. Sine x over x is the one that looks like this. It's got a hole at 0, 1, and then it looks like sine x, but it fades out as you kind of go way out there. And so way out at negative infinity, sine x over x turns into 0. So this thing equals 0 way out there. But we're trying to confirm the answer somehow using the sandwich theorem. So let's start with what we know. We know sine x is between 1 and negative 1. So if I were to take sine x over x, well, remember, we're looking at negative x's here. So I'm actually dividing by a really big negative number. So if I divide by a negative number, then I have to flip my signs. So this becomes 1 over x, and this becomes negative 1 over x. Remember, x is a negative number, so you got to flip them. Okay. So let's look at what happens as x goes to negative infinity to negative 1 over x, right? And compare that to this guy. And compare that to this one as well, right? Well, if I plug in a huge negative number in for x right here, I get like negative 1 over negative a billion. Well, that's basically 0. X goes to negative infinity, sine x over x. And then if I do the same thing on this side, if I plug in negative a billion right there, well, that's 1 over negative a billion. That's also 0. So essentially what I've done is I've told you that 0 has to be bigger than or equal to this limit, which has to be bigger than or equal to 0. So that forces this guy to get squeezed or sandwiched into the value of 0. Okay, so, and that's how that works. I hope that makes sense.